So, for this problem, I want to use Stoke's Theorem to evaluate that integral. And let me just write out what Stoke's Theorem is for you guys. So, Stoke's Theorem is saying that this double integral, called f dot ds, these are both vectors, over some surface S, is equal to the same thing as the simple line integral over the curve of f dot dr. Now, truthfully, sometimes the line integral is harder, and the curl is easier, or that's the other way around, and the curl is really hard and the line integral is easier. Now we're going to find out which one we're going to use in this problem. Okay, so we see that f is this vector function right here. Okay, and then we see that s is part of the sphere, and it lies above the plane, z equals 1, and it's oriented upwards. So if I was to draw this, okay, I drew it. First drawing came out really ugly. Okay, now notice that it looks like the sphere is levitating. That's because it kind of is, because we say it lies above z equals 1. So this picture makes sense. Okay. So real quick, earlier I was talking about this integral maybe being easier or being harder, and this one maybe being easier or harder. Now, the way you can think about this is, the best way to think about it is, what is easier to think about? Right? So is the curve easier to think about for the circle? Like, it's just a circle, that's the curve. Or is the surface easier to think about? Semisphere. Now, I would argue it's easier to think about the curve because it's just a circle. Unlike this one, which is the surface. So, I'm guessing we're going to use this integral, but we need to use these two facts to help us get there. Okay. Now what I mean by that is we see that x squared plus y squared plus z squared is equal to 5. But then we see that z is equal to 1. So, and this picture says that, hey, if we want to talk about the curve is where z is equal to 1. So we're going to insert z equals 1 over here. So I'm going to insert 1 here. And then we can see that this turns into x squared plus y squared is equal to 4. Right? And then we know that this is a circle with a radius 2. And we know that it's a circle that goes from r is equal from 0 to 2. And theta goes from 0 to 2 pi. Okay, so if we use this, what can we also think about? Well, if we use this, we need to talk about what dr is going to be. How do we find dr? We need to talk about what r is going to be. And by the way, this is big R for radius, little r will stand for our parameterization vector. So that vector is r is equal to what? X, y, and z. Now what is x and y and z equal to? Well, x we usually write as big R cosine theta. And we know r to be 2. R equals 2. So then the next one I'll write r sine theta. And we said that z is equal to z. Then we know that z is equal to 1 in this case. So we know that this is truly equal to 2 cosine theta, 2 sine theta, and 1. Okay, but this is just r. We need dr for our formula. Back hurts. So we do dr is equal to what? It's going to be negative 2 sine theta, 2 cosine theta, and 0 d theta. I need to use a bathroom. Okay, that was great. Okay, now this is dr, but we need what f is, and we do have f, but we have f in terms of this stuff. So let's put f in terms of what r is, right? So we said that x, y, and z is equal to this x, y, and z. This is x, y, and z, right? So we had our original vector f, which was x squared y z, y z squared, and z cubed e to the xy. So if we insert our stuff into here, so x squared is going to be 4 cosine squared theta, and y is 2 sine theta, and z was 1, okay? And then what's y? Y is 2 sine theta, and z is just 1, so just 1 squared here. Z cubed is just 1. E to the xy is e to the And there's a 2 and a 2 here, so it's going to be 4 sine theta cosine theta. Okay. Now, before you worry about this, notice that we're doing f times dr. Okay, so then we do f dot dr. We see that there's a 0 here, and there's, oh, look at that. We don't have to do that. Okay, look at it. But we do have this times this, and we have this times this. So we get negative 2 sine theta times 8, 4 and a 2 here. 8 cosine squared theta sine theta. And then we have 2 sine theta times 2 cosine theta. So that's 4 sine theta cosine theta. So this is your integrand for this formula. And we know it goes from, theta goes from 0 to 2 pi. Let's simplify this a little bit. So there's a negative 2 here, and there's 8 here. And there's a sine theta and a sine theta here. You can write this as negative 16 sine squared theta cosine squared theta. And the 4 sine theta cosine theta. Right to the edge. Pi. But now let's integrate this from 2 pi to 0. And I will drag this guy over here. One second. Messing this up. There we go. And this guy will be from d theta. Okay. Okay, and now I want to show you guys the tricks that we're going to use to integrate this. Because there is tricks. Okay, where is it? Oh, no. One second. Here we go. This is the trick here. So sine 2 theta, 2 sine theta, cosine theta. And you're like, how do we make this look like what we have on the paper? And I'll show you. Okay. So we'll go in black now. So formula was sine 2 theta is equal to 2 sine theta cosine theta. And let me just double check. Yes, it is. Okay, so notice that we have this one right here. So for us, our 4 sine theta. Actually, before we do that, let's actually think about this guy here. So notice that we have a negative 16. So we have a negative 16. And we shouldn't worry about that negative 16 right now. So we're just going to worry about the sine squared theta and cosine squared theta. So if we have the squares of this, right? Squaring this thing right here, right? Sorry, let me restart this. Give you guys a better explanation. So we want to use something like this for this guy. So if we take the square of this side, we're going to get 4 sine squared theta cosine squared theta. And then if we take the square of this side, since we have to do the same to both sides, then we get sine squared 2 theta. Right, so this now looks kind of like this. So for us, negative 16 sine squared theta cosine squared theta is going to look like what? It's going to be negative 4 times this guy. So if you times this guy by a negative 4, you have to times this guy by a negative 4 for math to work out. So then you get negative 4 sine squared 2 theta. Okay, so this guy, you'll use it and replace it. Okay, and you notice that we have a 4 sine 2 theta here. So 4 sine theta cosine theta. Well, this looks awfully similar to this one, except this is 2 times larger. So if it's 2 times larger, you have to times this guy by 2. I get 2 sine 2 theta. Okay, so now if we rewrite our integral, it's going to be from 2 pi to 0. And this will be, we'll have negative 4 sine squared 2 theta plus 2 sine 2 theta. That's what we'll have. This will be our new integrand. And this will be our new integrand. Right, again, so if we had 2 here, We times it by 2, then we have to times this by 2. So this is our new integrand. It's a lot nicer and simpler. So I'm going to break this up into two integrals here. Now, real quick, we do have a sine squared here. What does this mean? So it means we're not completely done. So sine squared, where's that guy? Right here, sine squared theta. So basically what we need to do is we'll write down the formula, and I'm going to try to make this a little bit easier to think about here. So sine, right, sine squared, and instead of using theta, I'm going to use u. Sine squared u is equal to 1/2 1 minus cosine 2u divided by 2. Okay, but we want, what do we want? We want something like this. So we have -4 sine squared 2 theta. So what that means is that, okay, so if we have -4 here, then we have to have a -4 on this side. So essentially, if you times this guy by -4, you have to times this guy by -4. So this is -2 then. Okay. And then the 1 stays the 1. And then we have 1 minus cosine. Now notice that this is 2u. Now, real quick, this is why I did this. Because I did this earlier and it didn't come out too, my explanation didn't come out too nice. Now note that u is equal to 2 theta, right? That's what this is implying. See, u is here, and there's 2 theta here. So, well, yeah, u is equal to 2 theta. That's how we can make this trigonometry into work for us, right? We want to make it work for us. So over here, there was originally 2u, so we're going to have 2u, which is 4 theta. Okay, now this is your new thing, and you're going to replace it. So your new integral, in green, I'll write it, it's going to be from 2 pi to 0, and it's going to be -2, 1 minus cosine 4 theta, divided by 2, right, plus 2 sine 2 theta d theta. This is your new integral, okay? And this new integral, and sorry, real quick, yep, yeah, this is your new integral. It looks, doesn't it look a lot nicer? Real quick, let me just even simplify it a little bit more. Okay, I'm going to times out the -2 in here, so it's just going to be -1, it's going to be -2, then plus -2 times -1/2 is 1, cosine 4 theta, plus 2 sine 2 theta d theta. So this is your integral, and of course I'm going to make more space. Okay, so let's integrate this guy now. So 2 pi to 0, and I'm going to break it into 3 integrals. We'll have -2 d theta. Then we're going to have this other integral here, which will be 2 pi to 0 cosine 4 theta d theta, and then plus 2 and 2 pi to 0 sine 2 theta d theta. Okay, and of course I'm going to give you guys names, I1, I2, and I3. Okay, so if I integrate I1 is going to equal to what? -4 pi. Okay, that was our easiest integral. I2 will be a little bit harder. I2 is going to be what? It's going to be sine 4 theta, right? Then divided by 4 from 2 pi to 0. And then insert 2 pi into here. So cosine of any even integer of pi is 0. Okay, I3, it's going to be 2. Oops. It's going to be 2, and I'm just doing these directly from here. So it's going to be negative cosine 2 theta. Then what? So remember, I'm doing this integral here. Divided by 2. 2's can cancel, and this is being evaluated from 2 pi to 0. And by the way, I know this is 0. I also know this is 0. And I know these off the top of my head. Not because I memorized it, but because I know that these are just... Think about it this way, right? Cosine, the cosine graph, the area from 2 pi to 0 under the curve, right? The area right? This area and this area is the same. Now, that's a really terrible graph, but you get the point. And real quick, if you don't believe me, I'll prove it to you. Factor out the -1 here. You'll have cosine. We'll insert the 2 pi into here. We'll have 4 pi minus cosine of 0. This is 1. 1 minus 1, 0. There you go. So I1 is your answer. 0. So you use Stoke's theorem to evaluate this integral. So you'd write this. 1 second. S curl f dot ds. Oh, no, it's not equal there. It's equal to -4 pi. There you go. So, a lot of work, but it came out really nice at the end.